Well, I think we can get started here. Good afternoon, everyone. Good morning, wherever you're at. Real quickly, the agenda. Thanks for joining us for the Simplifying CICD webinar here. We're going to do some intros, do some housekeeping, key concepts, current challenges, perceived value, what's happening out there, and then really talk about the basics. So hopefully, we really hope that we have a pretty good some value. We're going to talk some kind of background, war stories, just make this really engaging for folks and interested to talk to you all about CICD and our experiences with it. There is, on that housekeeping note, just note we do have questions. Just use the stream or the chat service on whatever you're streaming this on. We're streaming this to a couple different platforms, but we'll be able to see your comments. And we have a few poll questions too, and we'll give some instructions when we get there. So real quick, if you don't know who I am, I'm Joe Schneider. I'm founder, CEO of Dojo 5. My background's in embedded and electrical engineer, computer engineer. Did a lot of work in private industry and eventually kicked off Dojo 5, which is all about modernizing embedded.
Yep, and I'm Sean Prestridge. I'm the U.S. Applications Engineering Team Manager for IAR Systems. My background is also in embedded, specifically electrical engineering, software engineering, and mathematics. A bit of a factotum here, and try to keep my fingers in all the pies and learn as much as I can as I go through life, which is one of the things that makes this whole webinar really exciting. Is it's something that's relatively new to the embedded industry, and I'm really excited to get to talk to you about it and some of the things that we've done.
And my name is Rick Ryer. I'm an embedded software architect at Briggs Stratton. I lead up all of our embedded development here on the research and development group. And yeah, I've been an embedded developer for a little over 20 years now, and happy to share some our experience here.
Awesome. So we're going to kick it off real quick with a poll. So should be easy. Either go to that slido.com, enter that number. There's a little link spot for you to enter that number in, or else hit that QR code at the top left, and just let us know kind of what's your role within your organization. It'll help us kind of tailor some of the conversation as we go to the audience, which would be great. And while we're waiting for that, I'm curious from Rick and Sean, like what what do you see as good roles, like the which roles are you curious to talk to today? I guess maybe that's a good kind of discussion point while we're waiting.
My experience is certainly from the trenches, from kind of the developer role and kind of the operational side to get code from the test bench out to production. So that would certainly be my background and people I'd be interested in talking to.
Cool.
Yeah, and what I would like to see is what people are doing from the IT side of things, where they're trying to enable types of systems where you're doing cloud infrastructure building and what testing tools they're using, what frameworks, and how they integrate stuff in, or if they haven't even done that, simply because it seems incredibly complicated, and that's the whole reason you're here. So I'd like to know where people are in this particular regard, and that's why I think this is going to be a really exciting show for us.
Cool. And then, I mean, I'm really interested to hear from some of the like mid-level managers and stuff, because that seems to be one spot that things get stuck sometimes, is just understanding the value, understanding the needs. You got folks in the trenches that are, interested in making things better, but being able to kind of communicate with and understand those folks a little better and understand what they're looking for is would be valuable for me, I think. So yeah, really interesting. All right. We got there are probably some folks that aren't participating, but we do have one vote on the poll so far. we can just move forward here. And yeah, so we have at least one developer engineer on here. I think we're looking for others to get into, but yeah, interesting. We'll see if we can tailor some content. We definitely won't shy away from the technical piece of things. Interesting. Keep moving here, Patricia. All right. So this slide is just getting a common basis for all of us. The definition, challenges. The definition, I guess to kind of kick it off. It seems like lots of different people have different definitions of what CI is and CD. I won't ever forget. I think one of the earlier clients I talked to in my career. I asked them about unit testing in particular, not just CI, but unit testing. And they said, well, yeah, we do unit testing. And I said, oh, cool. How do you do it? And they said, there's a 400-page Word doc. And, the SQA guy goes through that. That's the unit test doc. And then the QA guy goes through that doc and, writes down, follows the steps and writes down, validated or not validated. Or verified, not verified, and is just kind of like, okay, wait a minute, we're talking about two completely different things. So I thought it would be interesting for us to just talk really quickly about what is CI and how does that work? What are some of the key concepts in it? I don't know, maybe you want to kick us off, Sean, or see?
Yeah, and to your point, the way I liken it to people is it's like the definition of time. Everyone knows what it is until you ask them to define it, and then they kind of struggle to actually define it, and they realize that there are subtle nuances between people's definition of it. And with continuous integration, typically the one thing that most people agree on is the fact that whenever you submit an artifact or source code to a build machine, your first pass warning system are the warnings and errors that are issued by the compiler. So clearly, if you have an error, it has to be cleared up or it doesn't produce any sort of object code or indeed a final executable. But there is this tendency to just say, you don't have to worry about those warnings, or to try to find a way to suppress the warnings in your compiler output and also your linker. And I always tell people, those warnings are bugs just waiting to bite you. They just haven't gotten to a point where they're going to bite you just yet. So that's kind of the first pass. But as you were mentioning, you need to have a test harness or a test framework that automates all of these tests, because it's not very scalable to have one software quality assurance person who's running through a document and all these different test cases that gives you the capability to be able to run these processes and these tests automatically. Because what you'd really like to see is something where it starts out once you submit the build, that it's going to run it through these tests automatically, and you get instantaneous or near instantaneous feedback on, is there a problem where it's not passing some of these automated testing? Because if you can do this early enough in the process while the developer's in the zone, then what that's going to mean is that they're still thinking about that problem, and it's actually easier for the developer to be able to address the issue that it's found. So that's one of the core key components. But there's a lot of other things that people want to use in a CI, and I'm sure Rick can elucidate more since he's down in the trenches.
Yeah, and we'll get into the details. Maybe just like the higher level, like what is this CI definition for you?
Right.
So in my experience, it's typically everybody wants to know, when's the build going to be done? And we want to make sure that what we generate and what we produce is repeatable and able to be confidently recovered if there is a problem with it at some point. Because of course, the first question you get back from the customer is, well, what code were you running? So we can try to recreate it, on our test setup. So for us, it's the confidence to know that what we produce, we can recreate, and then we can ultimately debug if we have to.
Yeah. Cool. Yeah. And that's, I mean, it's been, for me, there's a lot of like, the just continuous feedback loop, right? It's like the ability to um, like the second you start writing code, maybe even before that, when you start imagining what's going to go into this thing and some of your requirements, you start injecting bugs and you don't even know it. And I think that's the trick, is the finding out when those bugs are, how quickly, how early, and how effectively can you detect and then fix those bugs is really what it's about. Ultimately resulting in a quality system that allows you to very rapidly move as a company, and spit out quality firmware out the other end, really. So cool. Awesome. And I think, there's a lot of different why do it outcome kind of stuff that's here. I think there's so many different ways that that you can get value out of it. There's a bunch of different bullets. And I don't know, any one of those pop out to you guys as particularly, you want to riff on any of those in terms of value that you get?
Well, for me, it's the software quality, because, as I mentioned, it's a very manual process, that the approach that most people take towards testing. And there's the white box testing as well as the black box testing. And if the test cases are not written around some of the corner cases of where you can get into certain algorithms versus others, it makes it very, very difficult uh, to be able to have a whole lot of confidence in what you're putting out there. So I think the whole thing where you can get very near instantaneous feedback about, are you passing all of the regression tests, and indeed that can actually also give you some of the feedback about your test setup. Do I have all the test cases that I need and use cases? So I think there's a lot of things that can go into driving not only your current project, but also future follow-on projects that are going to be using that code base for future iterations of the product, that you can make it everything better. So I think there's a lot of ways that you can do that. And to me, that also foreshortens the testing cycle, because depending upon what the maturity of your organization, typically what we hear from people is that they spend anywhere from 30% of their time in a very mature organization in test and fix, up to 60, 70, sometimes even 80% of their time in test and fix, if developers are scattered all over the place and they don't have a high degree of experience in writing code. It can actually get very protracted very quickly. So I think anything that you can do to try to shorten that and get instantaneous feedback is going to be really great, and it will ultimately help to lower the costs. And I'll cede the rest of my time over to Mr. Ryer.
I would just amplify that. The corner cases where you hit, does your code not only operate correctly, but does it fail correctly? Do you catch your error cases? Do you handle them properly? And what happens when you don't get what you expect? That's where the unit testing helps. And that's where that fits into that CICD pipeline, to make sure that all of those are being executed. So when you make a change in some module deep down the stack, it doesn't create a latent bug farther up the stack where your customer is going to see it.
Yeah, exactly. Yeah, and one that I've really seen, I mean, you guys have talked about a lot of other pieces on that list of outcomes and why I do it, but I think, one that I've seen a lot is the transparency piece. It just like, especially as your team grows, as the complexity of your product grows, there's like a technical transparency of like, I don't really know what's going on under the covers, and if it works at the end of the line, then I guess we did it okay, whereas like CI tends to just like bust open that black box and really give me a lot of visibility into what's going on, a lot of confidence in what we're doing, and confidence that not only what we're building is high quality, but also that I can do it over and over again repeatably. And so that is that transparency, I feel like, is really, really valuable in my experience.
And I love your thing there on it works great on my machine. That was something that when I was doing embedded more regularly as a developer, that would be a very common refrain that you get, like, hey, I can't reproduce this issue. Well, of course you can't reproduce it because you're starting off with a pristine set of conditions in the memory and everything else. And typically when you find one of these really juicy little defects that you're trying to ferret out, it's not just the test case, but it's actually the things that happened before that put the memory in a certain condition that allowed that defect to manifest itself. And the really cool thing is that a lot of testing programs and give you that capability of finding, and not just those, but also code analysis tools like static analysis and runtime analysis give you the capability of finding those things much more quickly. So for example, if you do an array out of bounds access, if you have a dynamic analysis tool that actually keeps track of the array bounds and it sees that your code is accessing area outside of those bounds, it'll actually halt the core. And this is what our C-Run product does, and allows you to see, how did I get into this position? Because typically when you're doing array accesses and you get out of bounds, you're actually doing some sort of computation in order to arrive at what the index is for the array, and you've made some simple mistake. So for me, I'm the world's worst about going one beyond the end of an array because I prototyped the code in MATLAB, some algorithm that I'm working on. And then when I move it to C, I always forget that MATLAB is 1-based arrays and C is 0-based.
Oh yeah.
So that's
easy to do.
Yeah, it's great for me. But what that does is when you can use a continuous integration system to be able to find these things much more quickly, it means that the defect not only is found quickly, but it actually isn't found by your customer, which is something we all kind of want to not happen. We want to actually have as few firmware updates to our devices as possible, simply because we want to find all of these issues and defects before we ship it to the customer.
Mm-hmm. Cool. Well, I think any more to say? Anybody else on this page? We've got kind of we've kind of been all segueing into well, why do we need to change anything? Like we've got this. There's the CI concept I've heard of. Interesting. There's some value and transparency. Okay. But let's if we skip ahead here, we can kind of compare it to where people are at today. So this is kind of a fun graph of roughly what we've seen at some other companies to not be named. and I say that very in a self-degrading way because or a self-implicating way, because I've been in that situation before, and it's not for lack of passion or technical ability or anything. This is just kind of where things seem to naturally tend to when if you don't focus on the CI type of concepts, right? Yeah, works on Mind Machine. There's all kinds of great stuff here. Who's got a story about this that wants to talk about it?
Oh, the spaghetti code just brings back horror of when we were writing code in assembler and you were using some tiny little microcontroller that the jump instruction, the relative branch, could only do maybe 128 instructions. So you would have these veneers placed everywhere, like, okay, I'm jumping to the bottom of in between two functions here, which jumps another little bit down here. And oh man, I just
Yeah.
that brings back funny memories that I can laugh about now, but I'm sure my manager at the time must have looked at some of the code that the team was producing and went, oh my goodness, I can't believe this.
Yeah. Oh man, spaghetti stuff. No VCS. The number of times we've seen folks that are like, well, we version control in folders on Bob's machine. That's scary.
Hey, and yeah, that worked for a really long time,
You're right.
but
You're right. As
but
long as long as the hard drive kept spinning. Yes.
But I think that yeah, and but I think though your point is very well taken. But I think times were really different back in the good old days,
Mm.
mostly because in those days, let's just say the mid '90s, flash memory wasn't really a thing. I mean, it was around, but it was very expensive. Nobody used it. Everybody was using OTPs, the one-time programmables. And what this meant is that your firmware had to be correct before you shipped it out, because if you found a defect, you could do a running change, but it also may have necessitated a product recall, which is extremely expensive to do. And on certain devices, it meant that you basically had to junk all the units that were out there when you did a recall. So people were much slower and much more deliberate about rolling out a release. Therefore, you could do that with a version control system where it was just in a folder, because you only had maybe 1, 2, possibly 3 versions that actually got released out into the field. But nowadays, where we're doing like a minimum viable set of functions, where we're pushing out on an initial rollout of a product, and we're doing feature updates in kind of a more of a tornado development cycle. Um, you know, yeah, you remember
Tornado.
that?
Yeah.
Yeah.
Spaghetti tornado. This is getting very interesting. Yeah.
Yeah. Well, as people started doing that more and more, now you're having lots of versions.
Yeah.
And as Rick was alluding to, when you have different hardware revs of boards, it creates a configuration nightmare where
Hmm.
you need a much better system for version control than what we previously used.
Yeah. Yeah, and I think the like having all those folders or just having a few releases, like the fundamental idea of like I injected bugs at the beginning of the project and I only find them at the end, that was still happening even in that world, right? It happens today. That piece hasn't changed, but the idea that like so there's always this huge QA. Yeah, we've got quality over there. It looks like a participation badge. That's appropriate, right, for the good old days. Like we check the boxes and it should be quality, and it usually came at the very end and it was very mechanical. I like the gear there.
Yeah.
And it's just kind of like turn the crank and run quality. And then,
But
because then you get into all this, like, well, quality has a test plan that takes 2 weeks and you guys are pushing out the deadlines. I mean, I feel like probably everybody listening can relate
and
to
relate
some
to
of
the
those
well, you
conversations.
remember those old days where they used to have bug bounties,
Oh
where you
yeah.
got paid money for every bug that you found.
Code yourself
And
up a minivan. Yeah.
that's right, the Dilbert cartoon that took
Yep.
advantage of that. So I think the
That's right.
idea was great, but it definitely didn't encapsulate human greed and
Yeah.
human behavior. So
Oh goodness.
yeah.
Yeah, the X weeks of work over there where like we're coding and not integrating for weeks on end, right? And that also bit me so many times where there'd be one person that was working on submodule and for larger systems you gotta, break it up into pieces. But man, when you do that for weeks at a time, people are changing interfaces and maybe it's gone through 3 versions of that interface that they need. And you've been designing to something completely different. And then you just have this like merge hell, that's after the coding phase, but before the quality phase, I think, depending on how you do it. But it was,
And I think Rick, when you first got to Briggs, you guys were doing a pretty good job of making the transition from the ship it phase to, now you're looking at continuous integration, because I think if I remember correctly, you said that they had made a shift from being an internal combustion engine manufacturer to being completely electrified. So you completely flip the script on, hey, we only had 2 or 3 software engineers and everybody else was basically a mechanical or an electrical engineer. And now you've kind of gone completely opposite because of the electrification process.
Yeah, it was a big part of our organization's growth, and I think we were maybe a little farther along than the worst case of this slide, but definitely not the best case that hopefully is coming up on the next one, Joe. But as
we got a few slides to get to before we get to the best case, but yes, we're getting there.
As we've been traveling that journey, of course, you try to roll in, best practice from other industries and from past experience, and with the help of partners like Dojo 5 and IAR, it really helps get the process moving and get us to a point where now we literally just before I jumped on, we were running the release pipeline on a critical bug fix. Got the fix in with the pull request, pushed a tag, and I could jump on here because I know that the build pipeline's running. We're going to have a test binary automatically pushed to our automated test setup. And I'm hearing some dings in my background here that sounds like testing literally just finished here. So it can be multitasking here while I'm on with all you guys as we're pushing an update to our prototype code.
Did you script that? Did you?
Nice. I wish I did.
Awesome.
I wish I did, but no, unfortunately I did not. But it does time out quite well.
Oh, gosh. All right. Let's see. Yeah, I think we're ready to move on. We got a couple more poll questions. Get the folks involved here. So we kind of talked a lot about, what is the sort of some ideas of the right way. A lot of people have some different ideas about what the right way is. So we're kind of curious, and for those who are just joining us, just grab the QR code though, or head over to slido.com, enter that number, and then you can vote in our poll here, and we can learn a little bit about where you guys are at. But yeah, the right way. How often do we do things the right way? I think there's a lot of cases where with CI and then just other practices, it's like I know that this isn't right, but I'm between a rock and a hard place, or I don't have support from leadership, or nobody at my company wants to change. We're stuck in our old ways, or there's a lot of different kind of things. What you guys got any good stories while we wait for folks to vote here?
I still remember the old saying that why is there never time to do it right in the first place, but there's always time to do it over. And that's really true, and sometimes when you get a requirement spec, we get what we call the whiskey syndrome. Why isn't somebody coding yet? So rather than going through a design process and trying to figure out, okay, here's all the function points, how do we design code that actually has, when you're looking at your coupling and your cohesion, how do we design this piece of code correctly? It's, hey, you should be coding this afternoon. You got the design spec this morning. So, that's the one that kind of springs to my mind, because a lot of engineers kind of get into that bent, and managers as well.
Yep. Yeah, cool. All right. Well, we've had a few votes. Let's see where folks are ending up. Sometimes. And almost never. Nobody's saying always. Nobody's saying almost always. So that's really interesting, I think, is just, I think we all know intuitively that we're not doing things very well. So why do we keep on doing that is kind of the question. Oh, goodness. I don't know. I can't explain it. Any of you guys have any thoughts on that?
Organizational inertia is a big thing. I mean, that's a big thing. Organizational inertia, getting the buy-in from those that maybe don't see the value because there's always time to do it over, right? They just want to get the release out. We promised to release to the customer on, X date, and we got to get it to them. I don't really care what it is because we can always send an update, which, it's a common attitude I've seen in things, especially when you're behind schedule, because everybody's always behind schedule and didn't get it out where they wanted it to be. So
right.
There's never time to do it the right way, even though putting in the effort to do it the right way typically will save time on the back end. It's that initial investment that makes it so hard for people to get over that hump.
Yeah.
And I think it also has something to do with, with what they say in racing terms, what they used to talk about, Porsche, how it had so much weight on the back end. They would always say slow entry, fast exit. But it also applies to things like marathon running, because when you're doing software development, it's really akin to running a marathon. It's not a sprint. And so managers will see that anything that slows you down up front must be horrible, and they oftentimes don't have the perspective to see that slowing down a little bit up front allows you to go way faster at the end, because you've made correct decisions and you don't have as much technical debt on your design when you take the time to really think it through. And it's the same thing when you're running. If you start out slow, find your pace, there at the end, you've got tons of energy that you can use to accelerate and get across the finish line as quickly as possible. But if you burn yourself out quickly, you're not going to finish fast, if indeed at all. So,
Right, exactly. The other thing that drives me batty too is maybe you get, I don't know, manager reads like HBR or something, right? Some new hotness is out there. They buy a tool, and then but it's just a tool, no support, no cultural change, no strategy at all. It's just like, let's just airdrop this package into my team and hope for the best. And that has also failed in spectacular fashion that I've seen. They spend a lot of money and they don't actually change it to the right way.
yeah,
It doesn't take.
and one of the attendees said that the right way is very subjective. Never
Yeah,
seen a team of engineers agree on the way to do things. That is
exactly.
absolutely true.
That's so good.
That
Yeah,
that's
thanks.
really good.
Thanks for that. Awesome. We can move to the next one then. We got one more poll here. This is the last one, but it's really interesting to hear from all of y'all and see. So this one's all about, like, to what extent is your organization using something like CI? And we put some different pieces there in terms of automated builds, unit testing, hill testing, linting, code quality, managed build environment. There are, of course, others too, and feel free to toss in the chat if you've got others. But yeah, because like I said, some people will say, oh yeah, we're doing unit testing, and that's the 400-page doc that the quality team works on for 2 weeks.
Yeah, and Lint is great, except that there are so many more tools that go so far beyond Lint that are
Right.
actually
Static
not that
analysis is really what that should read. Yeah.
right.
Yeah.
But I mean, tools like our CStat, they're actually not that much more expensive than Lint,
Mm-hmm.
coupled with the fact that it goes way beyond. And one of the things that customers who typically compare our tools against Lint will say is that it has a lot less false positives than Lint, and it also
Right.
runs much faster. So, being able to get those results back real time or as close to real time as possible really has a huge benefit. And in fact, I wrote a white paper for IAR probably about 2-3 years ago. I can't remember exactly when, and we were talking about one of the papers I cited in there was an ACM paper that was submitted by a couple of engineers from Google, who showed that when you get that feedback is just as important as the feedback that you receive. And so their numbers, if I'm remembering them correctly, but I think I'm in the right ballpark, they said that if you wait until the next day before before the engineer gets the feedback, like it's a nightly build, then only about 22% of the time do they treat that feedback as serious, because of what they speculated was the survivor effect. Because once that code's in a nightly build, now it's going to count against your release metrics. So you have every incentive to argue that that's not really a bug. However, if you give them near
Sure.
instantaneous feedback, it was something like 73% of the time the developer would say, yes, this is something that I really need to fix and take care of. And so not only is it the survivor effect, but the developer's actually in the zone because they just wrote that code. They know what they were thinking. Because
Exactly.
I'm sure all of us have been in that where you're looking at code you wrote and go, what was I thinking when I wrote this? Because this doesn't make any sense. And you think
100%.
you wrote good comments on there if you're one of those types of people that actually does comment your code, which if you're not, you should be, but that's another conversation. But yeah, I think getting the feedback quickly, which is something that you can do through a CI/CD process, really helps developers to address those issues quickly and seamlessly.
Nice. All right, let's see what the results say when we find out. All right. And that makes sense, I think, in a lot of cases, right? Automated builds, that's kind of the starting point. If you don't have that, then a lot of this other stuff's pretty hard. Unit testing, managed build environments, awesome. Hill testing, linting, static analysis, and then code quality. I see 0%. And I think that's just falling off the slide slightly, but that is maybe not surprising too. Very interesting. All right, let's keep moving. We got a little more to get through here. So we talked a little bit about the values, the continuous feedback on code quality for the whole team, building a track record on the code base and the code base evolution, how it, how it's been, how we've been building quality into it, and how to prevent regressions, automated testing, code reviews. All of that just goes faster. I was just reading, so really interesting anecdote, and when we can riff a little bit, but so there's these set of metrics called the DORA metrics, and they're not specific to embedded. There's web and mobile, a lot of web and mobile really data points on it, but it's really, and I think Google either sponsors it or it has a big hand in it. And they came up with 4 key metrics that they monitor and measure as like key indicators of the maturity of a team. And one of the pieces that they're finding, and this is and you can go out and search on those DORA metrics, but like one of the key pieces that came out of the study, because the study for 2023 just came out within the last day, and one of the really interesting things they're finding is that the speed with which your team performs code reviews has a really big impact on the overall throughput of your team. And that's just really interesting in terms of like, I feel like when going back to my kind of like when I was green and first getting into the industry, that code review process was such a pain in the butt. And there's automation now and tooling and not only that, but like we would get in weird like religious battles about should there be spaces,
debates,
how should this be capitalized? We're using camel case or snake case or whatever, and it was just like, or you'd get in like should this be 5 if statements or 3 if statements, or could I do this with a switch, or who knows? It's just all this silly stuff that pops up, and you just churn so much time on little things. And I feel like when you get a good static analysis tool in place, when you get a good coding standard in place, so much of that melts away, and then you can have a very and without a loss in quality, especially if you have the CICD stuff in place, right, where you're okay, now you can get that code through the human quality checks, but the automation is taking care of all the tedium that normally would be just chewing up so much brain power.
Yeah, code reviews were always very painful. In fact, I had been involved in a couple of code reviews where fistfights broke out. So things got really testy with people like, why'd you write it this way? I would have done it this way. That's stupid. And then it goes downhill from there. But that, I think that's also part and parcel of what happens when you have people that don't necessarily want to be collaborative. They have that, what we used to call the 400-pound brain syndrome. They have all this knowledge that they've accumulated over the years with that company, and they guard it jealously. And they would give you answers that when you ask them a question, it was 100% correct, but completely useless, because they would not answer the question behind the question about what you're really trying to get at. They would only answer exactly what you asked, with typically monosyllabic answers. But to your point, I think part of the reason why the throughput can be measured by how fast you can get through code reviews is when you're writing very complicated code and you're using these weird little corners of the C language spec in order to try to condense 5 lines of code down into one, the code becomes kind of inscrutable, and it's very hard for people to understand what it is that that line of code is supposed to be doing. And I think that's one of the things that kind of slows down code reviews of what in the world are you trying to do here? Because this line of code makes very little sense. And the really interesting thing is that what we found is that when you start doing stuff like that, like trying to take 3 or 5 or whatever lines of code and compress them down into a single line of code rather than writing the code linearly, typically the compiler has to cancel a lot of optimizations in order to make very safe assumptions about what your code is doing. So if you write your code in a much more linear fashion, it's not only easier to read and review for a human, it's actually easier for the compiler to understand, and it will make better optimization decisions on the back end. And you get less of these problems of, well, there's bugs in the compiler because when I crank up the optimization, it doesn't work. Like,
oh gosh,
sure, there's bugs in the compiler because 95% of the time it's actually a bug in your source code. But I always tell customers, if your code can survive at higher levels of optimization, that means you wrote your code very well. But even if you crank up the optimization and you find that the code's not working, you should get in touch with us because we'd like to see a disassembly of it with the optimization turned on and turned off. Because if it's a problem with your source code, well, we can help you fix it and explain to you where you're getting into one of these weird rules of the C language spec. But more importantly, if it's a bug in the optimizer, we definitely want to address it. So I always encourage customers, don't sit on those things, ask. Because you have a chance to make your code better and or make the product better. So what's the harm? But anyway, I'll let Rick riff on that one.
I think getting back to CICD a little bit. I mean, everybody wants to generate good quality code. I don't think anybody who's been embedded more than a minute, wants to be able to put out good stuff. And part of that philosophy is to make sure that code reviews necessary evil, because I think we all could agree it's never good to grade your own paper, right? It's always good for someone else to take a look at it, understand what's going on, and make sure it conforms to the rest of the code base. And that CI/CD pipeline creates a great impartial grader, right? To go through and take a look at things that everybody has agreed to ahead of time, saying, yes, this is what we agreed to as an organization. This is how we want to attack things, and make sure that this conforms to the behavior we expect that we've written into our testing process. This conforms to our our coding standards, our visual stuff, naming conventions, camel case, spaces, tabs, all the things that we can argue about. We can settle on that and make sure that it all meets those standards before we actually ship code. And frankly, every time that new chunk of code gets integrated into that bleeding edge code base.
Cool. Let's keep moving. Code quality. We've touched on it a lot. What is good code? Code that I can read and understand quickly. Yep. That's one piece that gets understated a lot, is that readability of the code. But obviously that's one that's trickier to automate. But that's where I think from the CICD perspective, that's where when you get rid of I feel like there's a lot of folks that just don't simply feel like they don't have time to worry about that. They're worrying about something else. There's a hot fix in the field. I just got to hack in this fix, and that's where I feel like a good suite of tests, a good automated system that gives you confidence when you're working on that hot fix. You're under pressure, and you know what? To make this code readable, I do need to refactor it a little bit. Now, in traditional shops, it's like, do not touch any line of code that you do not have to, and certainly there's risk mitigation around that. But I have also been in organizations and worked on projects where we had a really solid suite of tests, and in that case, there was still high pressure. It's not like the pressure goes away, but then you have the ability to have confidence in making the changes and keeping the code up to date. That keeps it easily readable. It keeps the code reviews down. And then I feel like a lot of these techniques kind of build on each other, right? When you're building towards this modern, and we'll talk about that in a couple slides, but when you're building towards this modern culture, like a lot of them are very, like they build on each other. They just support each other. And so like getting one piece, of course, like get your foot in the door with just a unit test, or just have a code, like a coding standard, just get one of those in place. If you need somewhere to start, like don't get discouraged by all of the different things you feel like you might need. But as you start to add, it just like it grows, like the benefit you get grows exponentially from it, which I think is really cool.
When you're under pressure, that's the perfect time for standardization, right?
Yeah,
Because
and nobody wants to stop.
I'm going to make a quick little tweak, right? All I'm going to do is a little tweak, and this should be no big deal. This is a minor change. But you know what? If that brace isn't where you expected it to be, or somebody coded their if statement without a brace, or something, all those assumptions that you might make, especially when you're under pressure, you can just introduce, extra bugs or extra issues that then are a bear to go back and debug later. So frankly, that pressure hotfix scenario is the perfect argument for code standardization. So you understand exactly what you're doing when you're making a quick under pressure change.
Yeah, I remember the first time I was trying to support a legacy code base many, many years ago. The first directive I got from my manager was, if you don't understand what a line of code does or why it's there, don't touch it. And to that end, and I think that's really good advice, but if the code's not clear and simple, then how are you ever going to understand what the code is supposed to do? And the reason why it helps you move faster is because when the code is simple and you understand what it's trying to do and where it's going, it helps you more quickly spot any flaws in its logic as to where it's going, and also to be able to fix it much more quickly. So as you alluded to, Joe, and also Rick, you can't understate this enough that, you can't overstate this enough that code has to be clear and simple. For a myriad of reasons, don't write clever code, because if you think your job security is based on you're the only one who can understand the code, that's not job security. Your job security is in that you can write clear and understandable code, and you enable everyone else to a point where people don't want to get rid of you because you do write good quality code, not because
job
it's
security.
inscrutable.
Oh,
I had that happen one time long
on
ago where some guy, he used to make all of his variables his three initials followed by a random 3-digit number.
Oh God!
And when I asked him, why do you
That's
do
terrible.
that, and he's like, it's job security. So about 2 weeks later, he didn't have a job, and I had to retask somebody to rewrite those sections of code to try to figure out, what does this variable actually do? The code works, and it works relatively well, but it was just written in a way that you couldn't maintain it. He was he thought he would be the only person to maintain it.
Well, yeah, and one other thing I was going to say is there is some automation available here. One of the ones that we've used really well is or used to good effect is cyclomatic complexity, and it just kind of helps keep the size. You get a large functions or functions that have a lot of decision trees in them. It breaks them down. You can set up pipelines that will set a threshold. We don't allow code with complexity beyond this level, and that's a great way to start and start kind of pushing.
And when you're trying to work on the complexity and the cohesion, that's a really great way to keep it down, because then you can basically create unit tests that are actually effective, and then you're only testing whenever you make a change to a module, you're only unit testing that module and its interface, and then you kind of spot check the rest of the integration tests, and then you're good to go. So it's a really great way to build a lot of confidence in your code base very quickly.
Cool. Agreed. All right, let's move to the next one. All right, what's happening out there? Resistance. I'm curious to hear from folks that are on the line here, if they've got any ideas on where they see resistance. to adopting? What is the biggest resistance in your organization? Be curious to hear it. Or if for those that are already doing some of this, but we know that nobody thinks they're doing everything all the time. What's stopping you from doing that? But yeah, I mean, common legacy tools. We kind of talked about that a little bit already, but like kind of that, sometimes those can be a barrier. If there's tools that don't have like a command line version of them, or tools that are very difficult to automate, have not been built with automation in mind, those can be really difficult to then. I mean, suddenly you've got a C coder who likes embedded, trying to like write a crazy 500 line bash script and like downloading a library that like does cursor or cursor movements to click a button on a GUI, and you're just like, oh my gosh, like we're supposed to be getting that feature out the door, and they're trying to do the right thing. That's the whole point, right? Is like they're really trying to they know that it's not, that there's a better way to do things, but there's a lot of technology barriers there sometimes that get in our way. Yeah. So anyone got good anything to add here?
The thing that I typically hear from customers is they're interested in it, but they really don't know where to start because it's a very complicated topic. The other issue that they have around it is that they just don't have the resources to be able to implement something like that. They think it's interesting, or they think they see the value in it, but they just simply don't have enough human resources to be able to actuate on it to move their processes to a CICD. So that's a very common refrain.
Yep. Yeah, I've also heard maybe there's just a recency bias kind of thing. Like, well, when we talked about a little earlier, right? Like, that's just not what we do here. Sometimes IT gets in the way. I've had that happen. We have to run some rogue IT under the desk, and then it gets found out, and it's like, well, no, you can't do that. You can't just set up a server. Like it's got to go through the proper channels, and that's where innovative ideas go to die usually. So.
And actually, I think part of that is they just don't know the things that you can do with it. And I think Rick had a really good anecdote on that.
Oh, really?
Yeah, I think Rick was talking about automotive because I think he and I are car guys, so we always tend to relate everything to automotive. But I'll let Rick tell the story.
Well, the analogy I found on this was, the concept of you got your brand new cars coming out here. Who knew 20 years ago that I needed to have a, key attached to my phone, that I could just come up and tap the car and open it? Or who knew that having a, automated driving was even possible, right? My 1972 Ford Fairmont works just fine. Thank you very much. Like, you don't know what you're missing until you see it. And once you hop in that fancy new car and go, wow, this is really cool. And, oh, you mean like it'll let me know if I'm drifting out of my lane or something, or it'll check that blind spot to make sure I don't hit somebody on the freeway. Well, that's really neat. You never know. You never know you need it until you've got it. And now pretty soon every car has that kind of stuff, the lane detection stuff and the sensors out there to make sure that, that you're staying safe when you're driving. So I think that the CICD process is similar to organizations. They're still cruising along in their classic car and it works just fine. And, it gets code out. Customers are happy. What is there to monkey around with it? And we as engineers sit there and it's like, but the Tesla dealership's right there. Have you seen this car? It's amazing, right? So that's maybe sometimes the struggle from the trenches up to the decision makers.
Yeah, I have a good anecdote with that. We just recently got a new sport utility for my wife, and when I saw this one that they had at the dealership had Super Cruise, I'm like, oh yeah, we're getting that. And she's like, what is that? And so I was trying to explain to her about the automated driving, showed her a couple of, oh, we don't need that. That's a $10,000 option to get the package with it and all this other stuff. I'm like, you know what? Let's just go to the dealership and drive it. So we ended up driving it, and I made her try it. And after trying it once, she was laughing so much about it. She's like, we got to have this. We have to have this feature. And I think that's exactly where people are with CICD. They don't really know what they're missing because they haven't had an opportunity to try it or see some of the things that it enables them to do, and to do much more quickly than they ever thought possible. And I think that's really kind of where some people are with their legacy, is just realizing that the technology has moved on in how we're developing, because we're developing in larger teams, we're developing faster. The team members are, for the most part, remote. They don't really collaborate like they used to in office spaces where you would have water cooler talk or over in the lunchroom, and this kind of helps to bridge that gap, in my opinion.
Let's keep moving. We're time's short here. I just want to briefly mention, we had the comment earlier about what's the right way is very subjective. And maybe this is a fool's errand, but I think at least at D5 and really the broader embedded community, we want to continue that conversation of what does the right way in modern look like. We do have a modern-embedded.com where we put together some pillars of what we feel are modern embedded. Would love to have additional content or shoot holes in it if you don't agree with something. We may or may not agree with you, but we would absolutely love the conversation, because ultimately it's really just building awareness that and building a place for people to kind of talk about what these modern things are. We can keep moving. And so like the basics, we've kind of touched on a lot of these already, but having some kind of orchestrator to kind of run your CI system, getting version control in place. That one should really be the first bullet. And then build analysis test tools that are amenable to running in a pipeline, like the IAR stuff, the BXARM tool, manage build environments. And then, we got just a minute or two here, but really interested to hear from you on Rick on what your experience was in getting things set up.
Yeah, I mean, we started with where I think a lot of companies are at. I mean, we had version control in place, all that kind of stuff. We development standards and stuff for our department, but it was still built on, somebody's machine, and, we have to manually put the file in the right folder and all those kind of things. We had plenty of talent here to be able to do that kind of stuff, but is the constant thing, right? Well, we probably know 70% of what we need to do, and I'm sure we could research the other 30%, but of course that takes time, and that doesn't generate anything that, you can sell. So, how do you prioritize that into your work process? And so, working with IAR, working with Dojo 5, I mean, we were able to get our full setup, that I would say is coming quite along to where we want it to be from a fully automated standpoint, right? At this point, we've got a hardware in the loop tester, so an actual hardware setup for our product. We've got the unit test environment, so specifically pulling apart each specific class, each specific software module, and testing inputs and outputs against, positive numbers, negative numbers, null pointers, all the things that can break things, at a module level. And then, and of course, that can always get expanded more. But then the build pipeline that Dojo 5 helped us put together, that frankly, we just needed to talk to Joe and his team, and, magic happened, and poof, now we're running it. I mean, it's fantastic. So
awesome.
At this point, as I mentioned, just before I hopped on here, we had a hotfix we pushed. We got the pull request into the development branch, pushed a tag and said, yep, this is going to be our hotfix release. And I hopped back on here. And as we were going, the build pipeline cloned a fresh image. It sent it automatically over to the Hill tester. The Hill tester ran its suite of hardware tests. The unit test went through their full regression test. All that gets approved. Then it goes through the security mastering through IAR Secure Things and Security Suite. We get all that put together, and it automatically loads all of the executables into our cloud storage that then gets distributed through our phone app. So the QA team basically gets a little alert on their phone that says, hey, we got the hotfix ready, start testing it for your full, in-product regression test and safety testing. So I literally, I just tagged the commit and hopped on the webinar here, and already the QA team's working on it. So to me, it may not be perfect, but I'll tell you, it's a heck of a lot better than we were at, 6 months ago.
Putting the magic in automagic.
There you
Indeed.
go. Nice.
And again, none of that was things that, engineers can't do, for crying out loud, but Dojo 5.1 has the experience, so they already know the full 100% of, what to do. And they're really efficient about getting it set up and going. They were super amenable to the customizations and the things that we thought were important in our build. And they got us set up with a really good pipeline that then we can show to the greater organization and build that confidence and show that transparency in our release process.
Start the culture change.
Yes.
Yeah.
And
perfect.
we're already seeing it. We are already seeing it, that people are accepting the results of those tests. And there's a lot less hand wringing around a new release because it goes through the standard process. And you know what? The build chain does it.
Yeah. Awesome.
And you guys have worked hard to build a lot of confidence in your test process that is just automatically done by your CICD process, which I think is great. And that's really the whole point of what we're trying to do here with CICD, is to make it where you can have a lot of confidence very, very quickly.
Exactly. I think we can jump to the summary slide since we're wrapping up here. We had one more little graphic that was the amazing, end state, but I think we've kind of covered that pretty well. And the summary here is just there's no need to resist. You can do this. Solves a lot of problems necessary for a modern pipeline, and there are tools and technologies available today to help you do this. So with that, I really want to thank Sean, you and IAR's support in helping this webinar, and Rick, and definitely thank you so much for all your input and your great kind of experience story. I really appreciate that. And thank you to everybody who jumped on and watched us. Recording will be available too if you'd like to reach out. But thank you to everyone. It's great.
All right. Have a good day.